All right, so let us go ahead and check out this video with working some free response questions with the calculator for AP Calculus AB. For this particular problem, we will need a graphing calculator, and we are given our information that tells us that people enter a line for an escalator at a rate modeled by a function r. And so here we have our function. And it tells us that r is people per second. So we've got our people per second, and t is measured in seconds. All right, people get on the elevator, they exit the line at a rate of 0.7 persons per second. Okay, so how many people enter the line for the escalator at time intervals 0 to 300? To solve part A, we're going to have the integral from 0 to 300 of that rate entering the line equation, because that'll give us how many people enter the line. All right, and we'll need our calculator to determine that. So I can come over to my calculator. Let's go ahead and turn our calculator on. And I've already taken the liberty to enter in my rate equation. Notice that you want to be careful that you have entered in your rate equation with numerators and denominators correctly as entered. So I'm going to go ahead and make my calculation. Let's go ahead and clear these out. And so go to my integral calculation, integral from 0 to 300 of my rate entering function. As I do that, I see that my result is 270. So 270 people. Then part B. Part B asks, tells us that there are always people in line for the escalator. How many people are in line at time t equals 300? All right. Well, in line at t equals 300, we're going to have the people already there. So the people already there plus our arrivals minus our departures. Okay. Well, already there is 20. Arrivals was 270, and the departures is 0.7 per second, and that's 0.7 over 300 seconds. So that would be 20 plus 270 minus 210, which would be 80 people. So there are 80 people in line at time t equals 300. And once again, we got that without any calculus. How many people are already there? 20. How many people arrived? 270 from part A. How many people left? Well, 0.7 per second over 300 seconds, that's 210 people. Okay. Then for part C, let's go ahead and change the color here so we can distinguish our work. For part C, the first time there are no people in line for the escalator. Okay, so in minus out will equal our rate of change, right? So in minus out is going to be equal to our rate of change, and we want there to be no people in line. So in actuality, we need, the number of people at 300 seconds to all leave the line, right? So that's 80 people, and they're leaving at a rate of 0.7 people per second. So 80 divided by 0.7 people per second. If we do that on our calculator, let's go ahead and check that out. 80 divided by 0.7, that gives us 114.285. We can simply truncate. So that is 114.285. And once again, if you were rounding, it would be 0.286, but AP Calculus allows for truncation. So we can say 114.285. So number of people at 300 seconds to all leave the line. So that takes 114 seconds. So therefore, right, at t equals 300 plus 114.285, there will be no one in line. And technically speaking, we could have done this without a calculator and just said 300 plus 80 divided by 0.7, and that would have been a satisfactory answer. Then for part D, to the nearest whole number, right, it says to the nearest whole number, what time t is the number of people in line at a minimum, and how many people to the nearest whole number? Justify your answer. So we need to think about our justification, and we need to think about the solution approach. So we want minimum people. Okay, so minimum people will either be when t equals 0 or t equals 300, or when in minus out is equal to 0, and this is going to be based on the extreme value theorem. Okay, so that means we need to figure out these different locations. So I'm just going to go ahead and set up time t, right? And for time t, we're going to check out our number of people. Well, at time t equals 0, we know our number of people is 20. At time t equals 300, we know our number of people is 80. Then we need to continue with the other portion. So let's go ahead and come to y equals. So this right now is how many people are getting in line, right? Minus 0.7 is going to be how many people are leaving. So that's going to be our rate. And I want to look at, right, from 0 to 300, and I want to find when the people leaving minus the people arriving is close to 0.7, right? And it's a little bit hard to see here. I'll apologize for the overall difficulty on seeing. Let's see if I can adjust the focus on this to get it to zoom in a little bit better. Right, so that zoomed in a little bit better. And we can see that it appears that we have an intersection here and an intersection there. So I'm going to go ahead and calculate the intersection between my graph and my y equals 0. And it gives me one intersection of 166.574. So 166.574. And then let me go ahead and come over to second calculate. Let's pull that up so that you can see it. And we're going to find our intersection. And with our intersection, right, I'm setting up on the x equals 0, or rather the y equals 0 equation, and I want to find that first intersection. And that gives me 33.013. Okay, so I need to figure out how many people are in line at each of these times, right? How many people are in line at each of these times? Well, I can do that by coming over and saying, all right, so do my integral from 0 to the first value, 33.013, of my function And that, once again, is the in minus out function. And so that gives me negative 16.196, which is actually the net change. And I initially had 20 people in line. So if a net change of negative 16, then that gives me 3.803 people. So that's 3.803. Then I can come and check out the other portion and say, okay, well, what about that number, right? Plus how many people went and changed from, what was it, 33.013 up to 166.574 of my in minus out rate. And that gives me then 158.070 people. So therefore, at t equals 33.13, we have min number of people of about 4. All right, because it does say to the nearest whole number. It does say to the nearest whole number. Now, how would the marking for this particular question go? How would the marking for this particular question go? For part A, did I set up the integral? I get a mark. Did I get the right answer? I get a mark. And it needs to be set up. No integral, you don't get either point. You must show the integral. Okay, for part B, consider the departures. You get a 1. Get the correct answer, you get the second point. And once again, if you don't consider the departures, if you don't somewhere write the information of considering the departures, right, which in particular is this portion, then you cannot get 2 points. You must show your work for these problems, at least the setup. So already there, plus arrivals minus departures. Okay, for part C, when is the time? All right, well, the time is at 300 plus 114.285, and that is our only value. There needs to be some supporting work, but that 300 plus 114.285, which will be 414.285. And finally, for the last portion, here, we have, right, the minimum number of people either when t equals 0 or t equals 300, or when in minus out is equal to 0. So here's where you have to be careful. It would be better for you to write r of t minus 0.7 as the in minus out rate. Because if all you write is in minus out without the actual notation, then if your final answer is wrong, you do not get this point. So better to write the r of t minus 0.7 to get that mark. Then, if you correctly identify 33.013, right, then if you correctly get 4 people, and then lastly, if you correctly complete the extreme value theorem, right? So you have to consider how many people are there when t equals 0? There was 20. How many people are there when there's 300 seconds? That would be 80. And when the in minus out rate is 0, which was at 3.803, or excuse me, at 33 seconds and at 166 seconds. So once I consider all of them, then I can earn all of the marks. But if I have a mistake, all of a sudden, this goes from 3 marks down to 1 mark if you don't show your work appropriately, and possibly 0 marks. Okay? So thank you very much for your time.